Okay, so now let's look at some problems involving the derivative from both a graphical view and from a limit definition view. So these are the two worksheets 6 and 7 that I'm going to do combined here. Okay, so the first one gives us a graph and asks us a bunch of questions. The first one is, where is the function not differentiable? All right, so I'm looking for places like discontinuities, sharp corners, cusps, vertical tangents. All right, and so what I see is if I move from left to right, I see I have this point right here at -1, discontinuity at 1, and sharp corner at 2. So -1, 1, and 2 are places where I do not have differentiability. So x equals -1, x equals 1, and x equals 2. All right, but we're going to dive deeper and see exactly what's going on at these points. All right, so let's go back and now let's answer the question, where's the function continuous but not differentiable? Okay, well, the sharp corner here, that's a place where the function is continuous and yet not differentiable. So x equals 2. How about the function has a limit but is neither continuous nor differentiable? Okay, has a limit but is neither continuous nor differentiable. All right, now if we look here at 1, we see there is a limit because we're headed to the point there. There is a limit of the function, but it's neither continuous nor differentiable there. At the point at x equals 2, it was at least continuous. It just wasn't differentiable. It has a limit, and it was continuous, but it wasn't differentiable. So x equals 1 is a place that had a limit, but is neither continuous nor differentiable. Now we want to know, where do we not have a limit of the function, not continuous, not differentiable? Okay, has nothing, has bad, nothing good going on there. And so what we have, if we look over here at -1, we do not have a limit because the function heads towards different places as we head to -1. Because it doesn't have a limit, it can't be continuous, and because it's not continuous, it can't be differentiable. So x equals -1. So now let's go and do some limit definition calculations here. So if I want to find the derivative of f of x here, remember f prime of x is, by definition, the limit as h approaches 0, f of x plus h minus f of x all over h. Okay, then apply it to this specific function. So f of x is 1 over x minus 1, so I'll be replacing that x with x plus h, so 1 over x plus h minus 1 minus f of x, which is 1 over x minus 1 all over h. And again, as a little shortcut method here, to get this resolved out of its 0 or 0 form, I could do multiply by x minus 1, x plus h minus 1 on top and bottom. That'll take care of my denominator issues. Okay, so I get, when I multiply this times this, I get canceling of x plus h minus 1. So I just get, limit first. I am left with x minus 1 minus, and then the second one I'm left with x plus h minus 1, and then all over h times x minus 1 times x plus h minus 1. Keep working. So on the top, in the numerator, I'm going to get x minus 1 minus x minus h plus 1. Okay, and I get some canceling of the x's, the minus 1 and the plus 1. And I'm just left with, I'm left with minus h. The bottom, I'm left with h, x minus 1, x plus h minus 1. And, as I was hoping, cancel, cancel. So I'm ready to put in h of 0. When I do that, well, let me first write it. The h's canceled out. Negative 1 over x minus 1, x plus h minus 1. And I get to put in 0 there. And so I'm actually just going to get negative 1 over x minus 1 times x minus 1, or in other words, negative 1 over x minus 1 squared. Okay, and this is f prime of x. There's my derivative. All right, let's try another one. Here's f of x. Still f prime of x, limit as h approaches 0, f of x plus h minus f of x over h. This time, limit h approaches 0, f of x plus h, so I put x plus h in for x, square root of x plus h plus 1, minus f of x, square root of x plus 1, make that a little too big there, over h. And I have what looks to me like one of those radical conjugate situations. So what I'm going to do is multiply by the radical conjugate, square root of x plus h plus 1 minus, no, in this case, plus square root of x plus 1 over the same thing, square root of x plus h plus 1 plus square root of x plus 1. I'm just looking at the changing the sign, that term there. Okay, so that's going to give me, so on the top again, remember I'm dealing with an a minus b and a plus b. When I get a squared minus b squared, I'll get x plus h plus 1 minus x plus 1, because both of the things just end up coming out of the radical. And then I get h times this whole square root of x plus h plus 1 plus square root of x plus 1. All right, in the numerator here, that's x plus h plus 1 minus x minus 1. And in fact, I end up just with, oops, I forgot a parenthesis in the denominator there. Oops, hold on. In the numerator, the x's cancel, the 1's cancel. I get the limit as h approaches 0. I get h in the numerator, and h times that whole mess in the denominator. As usual, h's cancel, and I get the limit as h approaches 0, 1 over square root of x plus h plus 1, plus the square root of x plus 1. And now I am going to take h to go to 0, so h there goes to 0, and I get 1 over square root of x plus 1 plus square root of x plus 1. I get 1 over 2 square root of x plus 1. And there I have it. F prime of x here is 1 over 2 times the square root of x plus 1. That's it. Okay, so there are a couple of examples of doing the derivative by the limit definition.